waiting for Tiago.
Yes, we are all here.
هنا حراوي Tiago, he joined through the attendees. I sent to him to join through the the personal invitation. He will join now.
Okay.
السلام عليكم ورحمة الله.
عليكم السلام ورحمة الله. مرحبا دكتور.
الله مساءكم جميعا، ويعني جميع الحضور، أشكركم جميعا على الحضور وهذه الفعالية. فيعني الجميع اكتمل، كل الحضور اكتملوا.
بالنسبة لنا احنا جانب بورينجر مكتمل الحمد لله دكتور، في انتظار سيادتك.
نرحب فيكم جميعا، واشكر يعني شركه يعني بورينجر المساهمه في اقامه ورشه العمل العلميه عن مرض الحمى القلاعيه في المسكرات والوضع الوبائي لذلك. طبعا يعني ايضا اشكر لجميع الساده والسيدات او الخبراء الموجودين في هذه الفعاليه. لن نطيل بشكل كبير، ولكن يعني مرض الحمى القلاعية كما يعلم الجميع من التحديات التي تواجه الصحة الحيوانية عالميا، ويعني تفرض العديد من القيود على حركة الحيوانات في العالم وأيضا على منتجاتها، وتسبب خسائر اقتصادية كبيرة في الثروة الحيوانية. لدينا في المملكة العربية السعودية أيضا المورد موجود، ويعني تعمل الوزارة مع جميع القطاعات على زيادة الوعي في مرض الحمى القلاعية والوقاية منه باستخدام أفضل اللقاحات المتوفرة. أكرر شكري وتقديري لكم، وأتمنى لكم إن شاء الله بإذن الله يعني فعالية ناجحة، ورشة عمل يعني مليئة بالمعلومات والفوائد، ويعني نبدأ على بركة الله.
شكرا يا دكتور. دكتور فارس.
I can hear you, Nahrawi. I don't think if Tiago joined or not. Tiago succeeded to join the call, Nahrawi?
I don't know. I didn't see his name in the list.
I just saw him, so I think he's here.
Yeah, he joined via wrong.
He's here now. He's here. He's
okay.
here.
Thank you.
Hello, good afternoon. Sorry.
Hi. No worries at all. You are on time.
Thank you so much. I used the wrong link, but it was not working. So now I'm in.
So now, Tiago, it is your part for the introduction. We are waiting you.
Okay, so can I start?
Yeah, you can
yes,
start.
please go ahead.
Okay, fantastic. Thank you very much. Good afternoon, everybody. Great pleasure to be here. And on behalf of Boehringer Ingelheim Animal Health, I would like to thank all the attendances and the Ministry of Environment and Water and Agriculture in the person of His Excellency Dr. Hali Hal de Werk, the Director General of Veterinary Health and Monitoring, for the collaboration and increasing of awareness among the veterinarians. I want also I would like to thank and welcome our business partner in Saudi Arabia, Al Ghusaibi, in the person of the Dr. Safwat, the General Manager of the Veterinary Division. It's a double pleasure for me to introduce the agenda and to say that the presentations will be done by three great colleagues of mine from Boehringer Ingelheim. So the first part of the presentation will be done by Dr. Mohammed Al-Narawi, where he will speak about the FMD disease. The second part will be about the epidemiology of the FMD in the Kingdom of Saudi Arabia that will be performed by Dr. Nicolas de Normandie. And the last part, the third part, will be about the vaccine characteristics that will be performed and presented by Dr. Stéphane Imbert. So again, on behalf of Boehringer, welcome to everybody to this session. And just to mention that in the end, we will have a summary in Arabic and a discussion after each session. Okay, so the floor is yours, Dr. Mohammed Al-Narawi, and again, thank you all for your presence.
Thanks a lot, Tiago. Before I start my presentation, I have to also thank Ministry of Agriculture for making this event happen. We will talk today about FMD as a disease and FMD vaccine. So the first part, I will speak about the disease itself, FMD. And after that, our expert, Dr. Nicolas, will speak about the epidemiology in Pole 3, which is our region, Saudi Arabia and the Peninsula. And also, Dr. Nicolas will continue to say how to prevent the FMD disease and will explain the largest FMD vaccine offer with the most important genotype 7 strain. After that, our expert, Dr. Stéphane, will speak about the characteristic of the good FMD vaccine. So before we going to the disease, I have to highlight that this webinar series will be in 5 series. The second one will be we'll talk about FMD immunity. and the VNT definition. And also it will highlight the FMD post-vaccination monitoring. The third webinar we will talk about how to choose the right vaccine and the role of R1 value and VNT on that. While the fourth webinar, we will speak about producing a quality vaccine against FMD is not an easy task. Of course, it is not an easy task. And the last one, we will speak about the good vaccination practice. So I will speak about the disease. And I don't know if you know or not that FMD was the first disease known by a human being affecting animal. So Dr. Girolamo Fracastoro, the Italian physician, identified an epidemic in cattle near Verona in 1546. Recognized after that by Frederick Loeffler and Paul Frosch in 1989 as a filterable agent, which is a virus of FMD. So FMD is the first known viral disease for cattle worldwide. And since that time, we have FMD-free countries and FMD endemic countries. And we all know the outbreaks happen in United Kingdom in 2001, not from a direct contact between infected animals, not through importation of infected animals, but through importation of contaminated byproduct used to feed pigs at this country. And this may give us how FMD can spread without the movement of the animal itself. That's why FMD is the most important viral disease on all the globe nowadays regarding to ruminants. So FMD is an extremely contagious viral disease of all cloven hoofed ruminant, affecting the domesticated and also the wild ruminant. It is endemic through many parts of the world, except Europe, North America, Australia, and New Zealand. Those are the countries, FMD-free countries. It is a transboundary animal disease that severely affected livestock production and disturbed regional and international trade in animals and the animal product. And as we all know, FMD is characterized by fever and blister in the tongue and the muzzle in the mouth, on the teeth and in between the hoofs. The disease characterized by a very high morbidity and low mortality in adult animals, but often high in young animals with the characteristic myocarditis. And also, we have to know that the virus of FMD is a very small one from the Picorna viridi, and it is RNA virus with 8,000 nucleotides. The virus has 7 distinct serotypes, A, O, C, Asia1, SAT1, SAT2, and SAT3. The most important 4 serotypes circulating in our region, POL3, is A, O, Asia1, and SAT2, with more than 65 strains within the 7 serotypes. And we also good to know that there is no any cross immunity between the different serotypes. The virus is a naked virus. It is not enveloped like the corona one. It is a naked. So it is resistant to the environmental changes. It can resist temperature above 50 degrees centigrade. Above 50 degrees centigrade temperature should inactivate the virus. Also, it is not sensitive to the usual disinfection, which is the ionophores, the quaternary ammonium compounds, and the phenol, but it do inactivated by the sodium hydroxide 2%, and sodium carbonate 4%, citric acid 0.2%, and also acetic acid. So depending on the environment, FMD survives 1 year at 4 degrees centigrade and 6 months in the slurry of the animals in winter. On hay and in straw up to 5 months and 70 days at 22 degrees centigrade, and also can be survived in urine for 39 days and in dry feces for 14 days and 10 days at 37 degrees centigrade. So this virus is survived well in the environment, and it is not easy to be destroyed, and can infect animals by direct and indirect contact. As we mentioned in England outbreak 2001, the infection come from importation of untreated byproduct to feed pigs from China. So this virus is highly contagious, and 10 particles of the virus enough to make or to initiate the infection by the inhalation route. So the portal of entry of this virus could be through different routes. All the routes of the animals could be a portal for this virus entry. The most important one is inhalation, because only 10 particles of the virus can initiate the infection. So the mode of transmission, as we said before, through direct and indirect contact. The virus also is excreted or secreted in all the secretion of the animal from all the routes. The most important route of infection is breath through the direct contact via respiration. It also can be transmitted through the milk, the meat, the carcasses of the animals, and all the equipments used in the farming operations. So FMD has devastating results in the farms, in the affected farms. It is as exactly a nightmare for livestock producers, causing direct and indirect losses. We have just to highlight that United Kingdom outbreak in 2001 led to slaughter of 6.5 million animals and a loss of 3.1 billion pound direct costs and 3.6 billion indirect costs in one country. So the direct losses of this devastating disease is the loss of milk production. This is the main loss, 25% drop in yield per year, and also loss of weight, induced loss of meat production, and fertility problems will came with increased 10% in the abortion rate, and also delay in milk sales and animal sales. We have to add also the cost of supportive therapy and the dead animal costs. The indirect losses is the movement control, the diagnostic tests, the culled animals, and also the emergency vaccination done and the extensive vaccination done is considered as an indirect cost. We have to highlight how to trace the infection of FMD virus, because it is very important to know the source of the infection. So if you have an infection, you have to find the first animal infected through determining the age of the mouth lesion. And after that, you can choose the highest risk period of infection, which is 2 to 6 days before the clinical signs appear. So it's important to mention that the incubation period of the disease may be extended to 14 days, but the most or the highest risk period is from 2 to 6 days. The high risk of virus shedding occur at the first day of infection and 3 days after that, while it is possible to excrete the virus in the environment of the animals 2 days before the infection starts and 4 days after the or 7 days after the infection starts. The clinical symptoms of the FMD is very characteristic. This blisters in the mouth, tongue, muzzle, feet, and teeth is very characteristic to the disease. The disease also associated with fever and anorexia with tongue protrusion, and excessive and droppy salivation is a remarkable sign with smashing of the lips and sucking the sore tongue. Sloughing of the tongue in severe cases did occur, with severe drop, even cessation of milk production sometimes happen, severe weight loss, and also lameness. And after FMD infection, we have a lot of mastitis cases related to the destruction of the normal defense mechanism of teeth and udder. There is complications of the FMD infection related to the permanent lameness, the permanent loss of weight, the chronic mastitis, and the permanent impairment of milk production. Also, as we mentioned, abortion may be raised by 10%, loss of heat control, and the death of young animal due to myocarditis, death of adult cows due to secondary infection. And when Nicholas will speak about genotype 7, AHS genotype 7, we will know also that the myocarditis can be happened in the mature animals. The clinical signs in sheep and goat are very mild. If any, sometimes the disease is circulating without any clinical symptoms in the small ruminant, but it can be fever, oral lesion, small vesicle on the dental pad, foot lesion, small vesicle between toes along the coronary band and interdigital spaces. Also, we might develop a secondary foot rot. Agalactia in milking sheep and goat is a feature. This of young animal may occur without any clinical symptoms, and this can make a diagnosis and the prevention of spread very difficult. We have to notice that sheep may appear healthy, but will be producing infectious aerosol or spreading the virus via urine, feces, or indirect or direct contact, and this has complicated the epidemiological situation of FMD in our region. The differential diagnosis of FMD, in cattle, we have to consider the blue tongue, the vesicular stomatitis, and the caustic substances. And usually in field, we belong FMD to the diseases cause oral lesion without diarrhea. It differentiates the foot and mouth disease from the other diseases causing oral lesion with diarrhea, like the BVD, the blue tongue, and many other diseases. For individual cattle, we have to differentiate the FMD from mucosal disease, malignant catarrhal fever, blue tongue, and from the disease of group of the sheep. Veterinarian should consider sudden lameness, such as in foot rot, blue tongue, and also PPR. The treatment of FMD, there is no any specific treatment of FMD. Vaccination is the only way to protect the animals from the foot and mouth disease. On the farm level, vaccination and biosecurity is the only way to protect your animal from FMD. We have to know that it is important to maintain animal welfare despite FMD symptoms. The topical treatment of the lesion is very important. To flush the lesion with 4% sodium bicarbonate solution. 4% is enough to kill the virus. Some veterinarians use a fully saturated solution from sodium bicarbonate, and this is not good to the tongue and to the sensitive tissue in the mouse. So only 4% is enough to kill the virus. Trimming and freshening the wound edge and remove the mucous membrane shreds. Drying the lesion with sterile gauze, and after that spraying for 3 successive days with mixture of gentian violet and oxytetracycline, which is it's very common in practice, the spray of gentian violet and oxytetracycline. It is not important to manipulate the tongue or the mouth of the animals because it is very painful for the animal, but just to spray the gentian violet and the oxytetracycline spray on the mouth of the animal, and the animal will lick this spray after, and this is the best way to do the spraying. Also, we have to inject a long-acting antibiotic and non-steroidal anti-inflammatory drug to avoid the secondary bacterial infection. Sometimes we have some animal with off food, and parental ringer solution dextrose 5% is indicated for the animal of off food. Now, it's well known when we have outbreak of FMD, it is important to maintain the animal welfare despite FMD symptoms. Another mixture of topical application of alum stone powder, molasses, and sesame paste is usually used in practice in our region, but we have to avoid the flies coming with the molasses. So if you find a lot of flies comes with the molasses, you have to stop using molasses because the flies will spread the disease faster than everything. Now we have to look to the lesions photos to know the aging of the lesion. It is important as we said before, in the tracing of the disease. So blanching of epithelium followed by formation of fluid-filled vesicle is the first and second day of the disease. And after that, the freshly ruptured vesicle characterized by bright red exposed dermis. It means that this lesion is 3 days old. If we look to this lesion at 4 days, we will find a sharp demarcation in between the red color and the yellow color. Deposition of fibrin start to occur, and that means this lesion is 4 days. After that, the considerable fibrin deposition has occurred and regrowth of epithelium at the periphery of the lesion. It means that this lesion is 5 days old. 7 days old lesion characterized by extensive scar tissue formation and healing also has occurred. Some fibrin deposition is usually still present in the 7 days old lesion. And why we do this aging to the lesion to know how to trace the infection, to know the source of the infection, how the infection come to this herd or to this farm or even to this country. The 10 days old scar on the dorsum of the tongue is very characteristic to the older lesion than 10 days. So again, I have to remind that the incubation period of the disease may be extended to 14 days, but the highest risk period is from 2 to 6 days before the clinical symptoms start. And also I have to remind that the very high risk period for virus shedding is the first day of infection and the 3 days after starting the infection, while the virus can be excreted also before the clinical signs start, 2 days before the clinical signs start. So I have to conclude this part of the presentation that FMD is the highly contagious disease. The morbidity may reach 100% with important economic losses, as we said, direct and indirect losses. The low mortality is a characteristic for this this disease. Only 1 to 5% in mature animals, but the virus did kill the young calves by the myocardiopathy. And also this low mortality complicated the spread of the virus because a lot of infected cows can transmit the disease for long period. The virus excretion is up to 14 days before appearance of clinical symptoms. This is the incubation period of the disease, and the massive quantity of virus is shedded, 1 million virus per cow per day. Many route of transmission for the virus with very low doses of the virus. 10 virus particle can initiate the infection through the inhalation route. Cattle, sheep, and goat, and 70 other animal species are FMD susceptible. All the cloven-hooved animal, the domesticated and the wild animals are susceptible to FMD infection, with more than 60 strains within the 7 serotype of the disease circulating in the region. No cross protection between each serotype. Now we will have the presentation of our expert Nicholas, and after that the first break or the break, and after the break the first Arabic translation session. So the floor is your Nicholas.
Thank you. I wait for you to stop the sharing, I think.
I stopped the sharing.
It's okay, great. I hope you will see my screen. Can you confirm that you see my screen?
Yeah, I see my screen.
You see my screen, huh?
I seen your screen, yes.
Okay. Thank you, Mohamed. Thank you very much for your nice presentation on the disease. So welcome to everybody. I will make you travel a bit since I will speak of epidemiology, and then I will focus about the importance of the G7 strain and how we develop a new strain for it. So I see my I don't know how to remove that, sorry. Excuse me, just hold on a second. I want to remove because otherwise it's yes, I can see better now. Otherwise I will, I've seen here. Okay, so you have 7 serotypes, as said Mohamed. O, A, C, Asia1, SAT1, SAT2, SAT3, covering 7 pools, and that's why we have to make tailor-made vaccine for FMD. Fortunately, I would say those 7 serotypes are not circulating everywhere, but in clusters or in pools. The first one is pool A, pool 1 in Southeast Asia, whereby you have only OA and Asia1 circulating. You have pool 2 in South Asia, the same, and the one which is interesting for us in Saudi Arabia is pool 3. Again, OA and Asia1 normally only circulating. Although there is sometimes incursion, like it was the case with SAT2 and in 2013, I think in Oman, and also in Israel in pool 3. So normally the SAT2, which are the South African territory strain, are limited to the pool of Africa, which are pool 5, 4, 5, and 6. 4 is Maghreb and East Africa. 5 is West Africa. I will show you my laser. And 5 is West Africa, and pool 6 is Southern Africa. Pool 7, we don't speak about it because it's usually only 2 strain, O and A, with only 1 topotype circulating in pool 7, which is Latin America. Here you have the map of, I made this map based on the OIE official status of FMD. As you can see, the green dark colored are for countries, for member or zones, sorry, it's very sensitive, which are recognized as free of FMD without vaccinations. and the light green are for members on zone recognized free with vaccination. So far, it's Latin America, which is actually starting to stop vaccination after many years of vaccination. What is circulating mainly in your area? Actually, the pool 3, as you can see, is on the crossroad, not only of the Silk Road and also from all the exportation coming from East Africa, but there is a lot of viruses in pool 3, and in particular also in Saudi Arabia with the pilgrims, with all that movement of people and animals. And in majority, despite all the number of serotype and topotype, the one which are really of concerns today, due usually to transpool movement from pool 2, are the Asia G7. We call it A serotype. Topotype means the geographical zone of origin Asia G7, which appeared in 2015. I will go to it in my last part in only 4 countries. And then for O, which is more prevalent, you know, in the world, I would say the problematic ones, which are really circulated, are the OMESA in 2001, MESA standing for Middle East, South Asia, in 2001, like India 2001, D and E, and the OMESA Pan-Asia 2 and 10 and Home 15. You will see that 2 of them are concerning for Saudi Arabia, meaning the 2001 E and N10. So again, just to remind you, it's the serotype, the topotype for MESA, Middle East, South Asia. Lineage is the name of these figures, Pan-Asia 2, and the sublineage. This nomenclatura is linked to a difference of nucleotide in the sequencing of the virus, but I will not go in detail for that. My slides are not moving. Super. Yes. We, with Boehringer Ingelheim, are working in team, and we are following and updating FMD epidemiology in a very close manner. We scrutinize everything, every event which is developed or informed on the website or during meetings. Today is on webinars. We have a regular cooperation with international organizations, the FAO, the OIE, the EU FMD, the Commission for FAO for European Union or FMD. We have cooperation with international reference labs, and that's the Dobrel FMD from TPI, from the Pirbright Institute in UK, which is the world reference lab. Remember, it's a reference lab for diagnostic. And also with ANTHES, which is a regional OIE reference lab also for diagnostic. And we work also with regional organizations like AU-IBA, African Union, Inter-African Bureau of Animal Resources, and with chief veterinary officers, and of course in the field teams, although today it's not easy to be in the field. We follow up a lot the official notification on WAHID, the World Animal Health Information Database, and I inform you that it has been re-updated, this software, by OIE. So those you can normally, it was not obsolete, but it was not that convenient. Today, normally the WAHID, it should be more easy to check everything about the disease, the census, all the tests, the vaccination. You have a lot of information, not only on notification on this software. And the non-official, like the rumors notification, we also scrutinize them carefully on the FAO ProMed software. We, as I told you, participate now virtually to regional roadmap meetings, lab network meetings. We have been invited for the FMD epidemiological and laboratory network meetings. We are also invited sometimes as a neutral, of course, because we are producer for the OI Regional Commission conferences. And also to the PPP webinars, for example, the public-private partnership webinars, because we consider it is very important to work with the public sector as the public to work with the private one. Another good tool, and I'm coming to that, is we analyze all the quarterly reports, which are now together made by Dobrel and EU FMD. Now it's a common quarterly report instead of monthly one from EU FMD and quarterly from Dobrel. Now they do jointly a single quarterly report. And we have a fantastic software based on Tableau, which is picking all the information, 2 types of information, epidemiological for mapping, which I will show you just after, and also R1 vaccine matching. And so we can accumulate that in our big database, which are actually making some of our even international lab a bit jealous because it's full of information. This is one of the map we can do. It is just here, it's very complex because I have listed all the serotype, topotype, and lineage circulating in your area, just highlighting what is occurring in Saudi Arabia, but I will go more in detail after. This is just a snapshot of what you can find on our Tableau software. I can browse it with different years. Here I've selected since 10 years all the proportion of samples in 6 out of the 7 pools with all the serotypes. I could go in my software in lower gradient. That means I could go on topotype, lineage, and sublineage, but otherwise it cannot be readed. You have to magnify it. But just to give you an idea how this tool can be relevant, we can see here that because it's linked with the number of isolates, of course, the samples are not always reflecting the existing reality, but at least you can see that in your pool 3, there is quite a lot. And that's why it's important to have a good vaccine for this area, for the pool 3, because there is a lot of circulation of virus. Here, it's just a zoom on the pool 3, where you can see the countries, including Saudi Arabia, just to show you the usefulness of our pool, or sorry, our software, excuse me, for Tableau. And with Tableau, we can also have more detail, as I told you, on serotype and type, lineage and sublineage. Here, it's a glance of what is occurring since the last 10 years, from 2011 to 2019 in pool 3. And you can already see with the color that regarding O, A are the most prevalent. And for example, Hom15 in the sublineage and Ant10, as I mentioned for Saudi Arabia, are the one which was of a concern because it was samples which had been sent, so shared to the Burrell recently. And for A, Iran CIS13, and as I told you before, but today less, the G7, which occurred in 2015, and less for the others. The same, just to show you that we can do it with only Saudi Arabia since 10 years again. So mostly A and O, and there was no SAT. And here the detail for Saudi Arabia with so 3 topotype and lineage for Saudi Arabia and sublineage in 2001D and E and 10. Usually today is the E, which is of concern, and the G7 in A, but so far there was no isolate. You can see that in my chart, you don't have data for 2019 and 20. It doesn't mean that I forgot to include them. It just means that no samples were sent to the Burrell. It is linked with the COVID, but not only. And on this following chart, I just want to tell you, this is an extract from the lab network meeting, where it shows that in general, there is a better sampling carried out at national and regional level, because you can see China, India are dark. It shows a percentage of samples from those countries, usually to their own laboratory. But the sending of those isolates of FMD to the World Reference Lab, which is here in UK in Right, are not very numerous. This map doesn't show that, but here on the right side, it was data which was provided to us by the Burhan. There was a kind of a test they made from 2009 to 2016. Only 40% of all their shipment, which although it's the biggest amount, was coming from Western Asia and Middle East, that means from your pool, but only 4 from North Africa and East, 14 from North Africa and Eastern Africa, and 3 only from South Asia. But another thing is, even if China or India, for example, are very dark, or Turkey, you will notice that in your quarterly report of the Burrell, there is almost no sampling, meaning that at a global point of view, we are not aware, because if the Burrell does not receive a sample, we as manufacturer, we cannot order them those samples to do the vaccine matching. So it's the principle of the iceberg. The reported cases at the global level is very minor compared to the unsampled or unreported FMD cases. So we invite all of you, all the countries, to increase the samples you could send to the World Reference Lab of Dubreuil. And for some countries, we can even help them to support them for the logistic of the sending of the samples if there is any problem. Now, how to prevent and control FMD? I will just go very briefly because it's something that that everybody knows. It's a basic things. You need to apply a good husbandry management. It's like what we are hearing today for COVID. Maintain clean premises, quarantine newly introduced animals systematically, disinfect incoming vehicles, visitors, and material, and avoid any contact with external susceptible animals. To be frank, the quarantine on animals is, to be frank, more applied in animals than in humans for COVID, but it is very necessary. Maybe that's why the FMD has not spread, although it's the most contagious in animal world. It has not spread like the COVID today in the world. Another solution, like today for COVID, is doing regular FMD vaccination. The principle is simplified as it is here: simulate a fake infection with dead viruses, because we're speaking of killed viruses or inactivated viruses for FMD, to activate the natural protection, the humoral and cellular protection. This will be more developed in the further webinars on immunology. And the condition for good effectiveness of the vaccine is to store the vaccine between 2 and 8 degrees Celsius, not more, and to vaccinate all healthy animals and at least 70% of the herd to reach this herd immunity. Again, something which is really not today reached in the human sector for COVID. As you know, it's very important for animals. What can you prevent through vaccination? I will just remind a few figures that Mohamed really nicely described initially in terms of indirect cost. First, the direct is the mortality. You will avoid mortality in cows and lambs. Some virulent viruses like the Aesia G7 can kill directly the calves with myocarditis. But in general, the indirect loss are the loss of milk, which can have an effect of 25% of the production per year, and a loss of weight as well, gained due to the mouth lesions, because it's so painful that the animals don't eat properly or cannot walk to browse the pasture. So it's around 20% of loss of weight per year and 10% of abortion per year, with also a delay in conception, a mortality, as I said before. So with a lower fertility, at the end, it gives less choice to the owner, the livestock owner, in his herd renewal. Now, for vaccination, how to choose the best FMD vaccine? We consider we have like 3 big 5 qualities for a good FMD vaccine. I will just develop for you, the first one, which is appropriate strains. That means we provide, as I told you before, a tailor-made vaccine with the good strains to protect against the circulating strains of your given country, of your country in Saudi Arabia. Stefan, after me, will develop the 4 other qualities. So quickly, a reminder about the multiplicity of the virus types, as described by Mohamed, with the 60 variant. We consider there is 7 serotypes. Again, OA, Asia1C, SAT1, SAT2, SAT3, with a particular official color. And I ask, usually when you make presentation, please try to always respect the color, because it's much more easier to interpret it when we all of us in the world community of FMD use the same color, which is the official color. And within this, for example, O has 11 topotypes. The one which are in action, I will say, circulating in pool 3 are MESA, as I said, Middle East, South Asia, the most common one, but also you had some incursion of, as I told you, another pool from East Africa 3. And the lineage and sublineage also can be numerous in addition to the topotype, but I cannot detail all of it because there is many, but it's just to give you an idea of the nomenclature of the virus. For A, you have only 3 topotypes, so that's why you will hear of A Africa or A Asia. The G7, for example, falls in this one. It's a Asia G7. Okay, Asia 1 has only one topotype, Asia 1 Asia, and you have others with SAT1, SAT2, SAT3, which is not interest for you. What the conclusion is, we have to offer a tailor-made vaccine with all these various vaccine strain composition to protect against the current or expected strains. BI proposed the largest vaccine offer on the market. If you look at BI collection, which includes all of that, except the two gray here from MSD, this is on the upper part of the chart is a general recommendation in high priority, medium priority, low priority on those particular serotypes. With the same color, it's easy for you, with OA, SAT2, Asia 1 in this different priority. But in addition to have with BI those recommended vaccine strain, we have even another list of vaccine strain, which makes us the biggest portfolio in the world. Now, of course, theoretically, any number and mixture of strain could be used depending on what is circulating. So if you add to the multiplicity of vaccine strain to add in a composition, plus the possible potency of 3 or 6 PDT, 50, or the different adjuvant you can use, oil or aqueous, or the bottle size, it makes an infinity of proposal, but usually we try to propose the best appropriate strains and formulation for a given country based on in vivo and in vitro test. Regarding the selection, two small comments about how we make a choice for a good vaccine strain. The detail of the vaccine matching will come in the future webinars, the 2A, 2B, and 3 on R1 and VNT on the titer. But here I just want to highlight two main points. Sometimes people want to have the closest sequenced vaccine strain, the closest to the virus circulating in their area. But as explained in one of these publications and others, we are considering that it is better to prepare a large spectrum vaccine, which is not only based on sequencing, which can be a sequence made from another local place. As an example, so it takes us usually 2 years to develop a proper new vaccine strain, because we have to respect the European pharmacopoeia and the GMP. But this longer last, but usually we are sure, almost sure, that the selection we make can last longer for cross protection and will have less mutation pressure. The example here below on the publication shows that some immunodominant strain that we have in our portfolio, like O-Manisa or O3039 or R22 Iraq, can protect widely and for longer compared to autogenous local one. It was the case here in East Africa, whereby it was proven that O-Manisa strain, which is a strain very known from the year 70s in Turkey, we found out, actually not we, because it's an independent body who did that, laboratory, they found that the O-Manisa, although from Turkey, that means not from Africa, was protecting better against many isolates from Africa and many vaccine strain extract from Africa circulating virus. The other thing is about the sequencing. It's related to what I said, because if you take a virus from another part from the local, you might have a different sequence. It looks different if you look at the phylogenetic tree. It can be a vaccine strain which is far in the phylogenetic tree from the circulating strain. But we consider it is not the priority, the sequencing. We prefer focusing on the immunogenicity. That means if we have good result in vivo of protection, that means good immunogenicity or good titer, we prefer that than to have a vaccine strain very close to the virus, but which might mutate or not being an immunodominant strain, that means lasting in geographical scope and in the time. So we are, I would say, against autogenous local vaccine. which can be quick to develop, 2 months. We prefer spend more time, but have a long lasting and without mutation pressure. This was actually detailed in one publication from the Braille where they says, I just quote what they say, our results suggest that predicting antigenic difference using only genetic sequence alone or by geographical location is not currently reliable. They say we found co-circulating lineages in one region that were genetically similar, as I said, with sequence, but antigenically distinct. That means not really protecting with a low immunogenicity. And I will finish, I will try to be quick because I took some time, with a concrete example of how we managed to and why we decided to develop a new strain. As I told you, it's very costly and it takes some time. It takes around 2 years. And when occurred this outbreak of Asia G7 or 18 in the Middle East, in your country, in Saudi Arabia, in Iran, and in Turkey and in Armenia, in August, sorry, September, as you can see, and then September and December in these 4 countries, we found out that initially it came from an Indian isolate on the 80s. And then for many years, it kept quiet. He went to Albania, but he didn't really protect. We developed a vaccine which is not really used today. And then it reappeared in 2010 in Myanmar, in Bangladesh, and suddenly in 2015 with high outbreaks. And later on in Nepal, Bhutan, and Israel. But today with the new AG7, we stopped the outbreaks in this area. What happened at that time? In September 2015, when this AG7 incursion, we tried to develop R1 with the existing strain. At that time, there was few. We found out that ARN05 show very low R1, although in other webinars, you will see that R1 is not only the prediction for protection, but at least it gives you an orientation. And the only one that we are using meanwhile was the Saudi 95. But the Borel conducted what we call a PPG. It's a test in vivo on animals, and they show only 56%. The normal should be 75% of protection. So we found that even Saudi 95 was somehow weak to protect, and despite the, I would say, acceptable R1. And so there was some incidents. There was a outbreak in some big dairy farm in Saudi Arabia. So we decided to develop a new strain. So we started beginning of 2016 to collect potential candidates, so isolates from the Borel. And we followed all the steps for the new strain development with special concern for checking the purity of the master seed virus, because as you know, it's key to make sure you don't jeopardize the GMP of your production sites, because you cannot enter any gem which have not been purified before. And this purity, normally it takes around 6 months. I will not go in detail, but it's a very complex thing. Some manufacturer will make you a vaccine in 2 months. For us, it's just impossible. So our position, as I said, is to develop industrial large spectrum vaccine versus autogenous narrow spectrum ones. That's what we did, and we did a test on many candidates, on many isolates, and we had our first industrial batch available at that time, and we did our first PD50 study in 2017. I will develop it. We had the regular submission end of 2017. We launched it in early 2018, and we had the marketing authorization on the Q2 of 2018. You can see it took 2 years to do it. We found that there was a much better protection with AG7, which we called it AG7 2015 versus the Saudi 95. So we, of course, we had to check the legitimacy of this new vaccine strain when we first had our first production, using the big database I told you on R1 value, and on the in vitro testing, combining the VNT heterologous and R1 value. It will be developed in the other webinars. And it showed that we had a much larger spectrum with this new AG7 2015 versus all existing in the portfolio. That means Saudi 95, or even IRE 98, IRN 05, R22 Iraq. And the second step, we did an in vivo test, the PD50, which I will develop after. So here, just the choice on the R1 we did at that time which were for us a kind of reassurance that we had good value. And it was based on this confidence index, whereby we use the heterologous VNT threshold and the R1, where we had actually, this one was mostly on the R1, I think, but we were using those database to just reassure us that we found a good vaccine strain. In addition, there was some a fourth regional roadmap meeting for Middle East. Some of you attended it in October 2017 in Amman in Jordan, whereby they mentioned, so this is from OIE and FAO, that there was some, the closest strain in terms of sequences was the Saudi 95, I would say, which was the closest candidate, but it was not the best. And they say new vaccines are available or to be developed, and they say we have to use them. But they say in addition to Iran, because we found out Iran was very different from the AG7. That's why they recommend to have in combination. That's why they listed it here, Iran and the new AG7, because they were two different. One could not cover the others. And here, and I will finish with that, it is a because quite relevant and quite impressive of this new strain we developed. It is the PD50, that means the in vivo test with challenge we carried out, which was quite promising. There was actually a poster which was presented. That's the poster which was presented in the global framework, I mean, of control of foot and mouth disease, sorry, in Korea in 2017. Research, sorry, the Global Research Agency. Jeffrey, yes. And the material and methods were used, which were used for this PD50 was, so we developed the PD50 according to the European pharmacopoeia with a vaccine formulated with low antigen content with the AG7 2015 on 17 naive cattle and young, as which is normally prescribed in the vaccination monitoring guidelines, because they are supposed to be naive, so there is no incursion of any other matter to describe the immunogenicity of these animals. So we did vaccination on 3 groups, one with full dose of the vaccine, 2 ml, and it was intramuscular, another one with a quarter of the dose, and another group of 5 animals with a 16 of the dose of the vaccine, and 2 control which are not vaccinated. And after 21 days, to leave time for the antibodies to be generated inside each animal, we did the challenge with the intradermal lingual homologous challenge. That means with the same virus as the vaccine. Just to remind you, it's a test which was done at WBVR, which is an independent laboratory in the Netherlands. So it's not us actually, it's an independent laboratory to make sure the data are really exploitable. And we did a monitoring, of course, of those animals at D21 up to D29 to see the reaction, the rectal temperature, and different scoring, and especially the feet lesions. That's quickly the results. You see only the animals vaccinated with a 1 in 16 dose, 2 out of 5 were affected with the disease, which are in red. And of course, the control were red. Otherwise, the challenge, the PD50, is not validated. So remember that. And here in detail, it is the same thing, but just to highlight you. So thanks to this very good protection, as you have seen, with a quarter or a 16 of the dose, with the complex arithmetic calculation, it shows that the vaccine was having a potency of 18 PD50. It means that normally 1 PD50 shows that in 1 dose, you have sufficient vaccine to protect half of the animal. So that means in the shot given, you have the protection, you have 18 times the dose sufficient to protect half of the animal, which is a very good security for protection. Another parameter interesting to know about this G7 field virus is it looks like that effectively this virus was very lethal, very virulent, because on the control, So the two animals were affected. There were FMD specific lesions, as I said before. One animal had 3 lesions. This is in bracket the number of feet affected per animal. So one animal had 3 lesions on his feet out of 4. And one had only 1 lesion, but he died soon after. So he didn't have time, I would say, to generalize the foot lesion, but he died before. Why? He died of myocarditis, which was here proved. So it was still accepted as validated as a control, because actually it's even worse than having the feet lesions on the at least 3 legs, which is normally what we used to see in a normal PD50. So it shows you that it's quite a virulent virus. Despite of that, all the batches we tested were showing promising serological potency. So the potency on 3 batches were done, as you can imagine, just before the 21 days to see how the vaccine will generate the antibodies, to measure the titer of antibodies in those animals after 21 days, including the one which was tested in the PD50. So this batch was the one tested in the PD50, and we use a mini payload of the vaccine. So showing that despite a mini payload, purposely we did a mini payload to make sure some animals will not be protected to be able to measure this PD50, and it was the case. For the others, when we did this serology, that means the measurement of antibody titers on 2 other batches, aqueous or oily, there was a different of them. We found also very good titers, which are shown here. So the first one, the one which was a mini payload, at 1.75 titer. You know, these figures shows what you normally see in the certificate of analysis. So it's a titer of antibodies. It's measured by the dilution of the neutralization test, because the gold standard test for that is the VNT. All that will be quite described in the other webinars. But it's just to show you that for us, in our conditions, based on thousands of animals which has been challenged, live animals, we had made a kind of correlation table for which, that's why we define usually a 6PD50 should have on a certificate analysis a titer above 1.42. Just remember, it's a log. When you have a figure of 2, it corresponds that you can dilute 100 times, which is 10 exponent 2, 100 times your serum, and it will still neutralize the virus. So 1.42 correspond to 24 dilution. You can dilute 24 times your serum, it will still neutralize the virus, which is very good. And you can see the first mini payload was above this 1.42, which is 6PD50 for us in our condition with our sensitivity of cells. And the 2 other batches, which were full payload, were quite above, around 3. So that means much above this 12 PD50. Another important, and I have finished with my presentation almost, a clear seroconversion, as you have seen, was observed with all vaccine batches, which confirms that the ability of the G7 2015 strain to induce a satisfactory serological response in vaccinated animals. And we were much above the minimum pass levels, as I said, not only on 1.14, but also on 1.42, which is equivalent for us of the 6PD50. Conclusion on Asia G7 is the acute deadly myocarditis, which has been shown on the curves I've shown you, occurring before feet lesions, show that this new Asia G7 strain is quite virulent and deserves a close surveillance and prevention through vaccination. And Boehringer Ingelheim, we have this Asia G7 strain in our portfolio since 2017. And today, not all vaccine strains focusing Asia G7 are using a new Asia G7 strains, but still count on former vaccine strains belonging to different phylogenetic clusters despite lower efficacy. So you have to be vigilant on that. And I finish with my part. I will leave the stage to my dear colleague, Stéphane Humbert. Yeah, there is a break. Okay, so I can wait, I can stop here.
Thanks a lot, Nicholas, just on time. You still have 4 minutes in your time, and after that we will have a break.
Okay, so if there is any question, I'm here. There will be other question afterwards, but if now there is one, it's okay. Or maybe
we can take a few questions. So there is one question: how was nuclear technology used in control of FMD?
nuclear technology, you mean like sequencing?
I don't know exactly what meant by nuclear technology, but this is a question in the.
I don't know I don't understand the question. We are doing, as I shown you, we are leaning on a VNT technique. This will be really well explained in the rest of the webinars.
Yeah,
you
okay.
know what we call the R1, the VNT, the virus neutralization test. We have a project for new technology to make a link with the sequencing, because now more and more we have some of sequence of the what we call the VP1 part of the capsid, one of the most periphery, and we want to make huge database that we have of sequencing and vaccine matching. But today it is just at the beginning, but it is something we are working on for the future in new technology. But so far, what has been proved that sequencing, as I said before in the publication, can mislead you. You can have a very close virus, but if the majority of epitope are not there, it might not last long, and your vaccine then will have the effect of mutation and will not last long in the protection. So we better really focus on the real neutralization, because the VNT, although being an in vitro, because we are doing that in the lab, it is based on animal really vaccinated and in a real neutralization between antibodies and live viruses. Whereas for the ELISA, it is antigen coated. There is no live viruses in it. It doesn't mimic the real reality.
Okay, thank you, Nicholas. There is also a very interesting one. Do camel can be infected with FMD?
Well, supposedly yes, but there is very few cases. We were not aware of any real outbreak of camel. I've worked 2 years in Somalia in my young period. I've never seen any case of FMD when I was there. And Somalia, you know, is a country which has the most number of camels in the world. It's 6 million around the population of Somali.
Yeah, yeah. And this is a disease of hoof-cloven animals, so camel may be contributing.
Yeah, there could be normally.
Yeah.
Theoretically, there could be, but there is not really case.
Yeah, yeah. So now we will have a break, and we'll come after 15 minutes from now for the Arabic translation first, and then our expert Stefan can start his presentation. Okay?
Okay.
Okay, to the break.
Thank you.